function notation. With function notation, this is really the same as y equals f of x. This just represents our function. Okay, like I said, it's basically the same thing as y equals. It just looks a little bit different, and people get it right, and it's really nothing that much different. So if I evaluate this, I have f of 2. What this tells me is that x equals 2. So when x equals 2, I need to take that value and sub it into that x fat. So I'm realistically just solving this. So if I have f of 2, again, I'm just subbing that 2 value into the x spot and simplifying. So I have negative 3 times 2 gives me negative 6, plus 7 gives me 1. On part B, I have a different function, g of x. Again, my x equals negative 3. I'm taking that value and subbing it into this x spot. Yes, it goes here, but again, that's just telling us the function name. We're just subbing into, realistically, just this side and solving. So 2 minus negative 3 plus 9. Well, 2, this ends up being 2 plus 3 plus 9. So we know that we have 14. Find the value of x so that the function has a given value. We're supposed to figure out the value of x. This is telling us this is what y equals. So you could think of this as y equals a half x minus 3. Well, this is what the y is. So this is negative 4 equals a half x minus 3. I am just solving for my x. So I'm going to add the 3. And over here I get negative 1 equals a half x. I know because this is a half, I need to multiply by 2 to both sides. So negative 2 equals x. For part 3, or example 3, the function d of t equals 300,000 times t, and that represents the distance that light travels in t seconds. How far does the light travel in 15 seconds? So realistically, t is 15, and I'm supposed to find d of 15. Okay, so just like example 1, we're just subbing this into our function. So d of 15 equals 300,000 times 15. This, I get 45, 5 zeros. So this is kilometers, that's my distance. Now for part B, I'm supposed to figure out how long does it take light to travel 12 kilometers. Okay, so this is, I'm trying to figure out what does t equal. So this is like example 2. The distance is my d of t, and I know that's 12. So I have 12 equals 300,000 times t. So I'm going to divide by 300,000. So I got to do a quick calculation. I don't know that off the top of my head. Point 1, 2, 3. Point 0.00004 equals t, and that's seconds. Okay, so once again, A function is just where you plug in whatever the x value is and actually calculate it. Or if they give you find the x, you're plugging that into the other side and solving for your x. Now let's talk about graphing our linear function. Graphing is just like what we've done before for graphing. Going back a little bit on your algebra skills here. If you know slope-intercept, go ahead and graph that way. We'll actually talk about it later on in this chapter, but if you don't remember graphing from slope-intercept form, that's fine. Let's do a table then. So we'll call this table graphing. If you don't know, like I said, the slope-intercept form or standard form or any other form on how to graph, you can always use a table. And this works whether it's a linear function or if it's something else. So when you're doing this, you're just picking values of x, subbing that in. Oh, I should make this work. And then my y values, or in this case, my function values of wx. You're just plugging them in and then connecting. So if I pick some values of an x, I always like to pick a negative. I'm going to pick -3, 0, and +3. And the reason I pick these numbers is because I have a fraction here. That fraction is 2/3. So whatever that denominator was, that's the number I'm going to pick. Make my life a little bit easier. So if I'm taking that -3, I'm subbing it into my function. So I have 2/3 times -3 plus 2. So I could just calculate this, and I get -1 plus 2, which gives me +1. I now have a coordinate that I can graph. My coordinate here is at -3, 1. Remember, x is left and right. The w of x is up and down. So 1, 2, 3, positive. There's a dot there. Now I'm going to do the same thing with the 0. 2/3 times 0 plus 2 gives me 2. Go ahead and plot that. Actually, I miscalculated that. I'm sure you guys noticed that. That should be -2 plus 2, which gives me 0. My fault. So this is actually here. I always screw that up. Easy math. Okay, plus 7 the regular 3. And I get 4. Okay, so now I'm going to use a straight edge. Notice I'm just using a pencil. And I'm going to connect my 3 values. Mine's not perfect, but it works out. I've got 3 values. I can connect it. Just like you know, I actually would prefer if you extend your graph all the way to the edge and not cut it short. Okay? So there's my function. All I did was create a table. I have my x value, my work, and I'm just subbing into that regular function and plotting those points. If you misplot, notice I just corrected mine. Not a big deal, since I did mine in pen. So that's our function notation. You're just taking your value, subbing it into the function, and calculating. It's just fancy notation. It's nothing to be scared of.